Hi class, today we're going to look at developing the Fourier series for waveform 7. Waveform 7 was represented by one single continuous straight line for the whole period. So this meant that we did not have to split up our time domain. We had one straight line equation. The slope was 2v max over t, and it crossed the vertical axis at negative v max. This particular waveform had odd symmetry, and you may remember that that means there will be no constant term and no cosine terms. So in our series, we will only have terms of this form here. We will not use this formula nor this formula, just the Bn formula. Okay, so this is the Bn formula. In place of v at t, I need to insert this binomial. Because it is a binomial, I actually have to open up the brackets. So you can see that that's what I've done in this step. I've just expanded, I've opened up the brackets like this. In the next step, I took Vmax out as a common constant. So I've written it out front in that next step. I've also indicated that this will be two separate integrals. The 2 over t here, I've now put in front of the integral sign. Similarly, the subtraction sign here is now in front of the integral sign. Okay, so when the Vmax is placed out front, of course, it is now gone from these two positions. So we end up with this. Now, this integral and this integral can be found on your formula pages, okay? So the one with the t in front of it will have this as its integral, and the other one simply becomes negative cosine, but with capital T over 2 pi n in front of it. Okay, so in the next step, you're going to see this in place of the first integral and this in place of the second integral. Okay, so again, here it is. In place of this integral is all of this. It is still preceded by 2 over t. This is the integral that becomes negative cosine. Since it's already negative, you'll see it's positive. And you'll also notice t over 2 pi n in front of it. Okay, so again, we replaced the two integrals using our formula sheet. Okay, now in this next step, I actually simplified the constants. So I did not touch this part at all. I simply multiplied all of this together. So I took this to be 2 times 2 or 4, but it is over 2 squared or 4. Also, we have t squared over t times t. Okay, so those cancel and all we're left with is Vmax on top of n pi squared. And you'll see that here in front of the integral. Then I also had to take this constant and multiply it by this one. And here the 2's would cancel and the t's would also cancel, leaving us with Vmax over n pi. So this is a much simpler looking version. And again, all I did to work that out, I took this constant and multiplied it by this one. That gave me this. Then I took the constant, multiplied it by this one, and that gave me this. Okay, it is time to evaluate by doing upper limit minus lower limit. And here, upper limit minus lower limit. So capital T and then 0 will be substituted where we have these little t's. Let me move this up a bit and I'll show you. Okay, so first capital T is inserted here. That gives us an angle of 2 pi n. Then capital T is inserted here and here. So that gives us a constant of negative 2 pi n and an angle of 2 pi n. Okay, so I put this capital T in throughout the bracket. Now I have to subtract what we will get when we substitute 0. So we're going to get the sine of 0 minus the 0 here makes the whole term 0. Okay, so again, I took capital T, I substituted it here, here, here. That gave me this. Subtracting, and now we go to the lower limit. We're taking 0, we're putting it here, here, and here, and that gave me this. Okay, plus Vmax over n pi. And now we do that same treatment here. First, capital T comes in, giving us the cosine 2 pi n. Minus, now we put 0 in, we get the cosine of 0. All right, the sine of 0 is equal to 0. So is the sine of 2 pi n, no matter what n is. If n is 1, you get the sine of 2 pi, which is 0. If n is 2, you get the sine of 4 pi, which is 0, and so on. Okay, so these terms are going to be gone. Here, the cosine of 2 pi n, it's also here. Those are always equal to 1. And again, that is regardless of your value of n. If n is 1, we'd get the cosine of 2 pi, which is 1. If n is 2, we get the cosine of 4 pi, which is 1, and so on. Okay, so we're going to have a 1 here and a 1 here. The cosine of 0 is also 1. Okay, so these two terms are gone. They're equal to 0. This term becomes negative 2 pi n times 1. These terms are each equal to 1, so in fact, we're going to get a 0 here when we do the subtraction. So that means all we have left is this times negative 2 pi n, negative 2 pi n times 1, which simplifies to give you negative 2 Vmax over n pi. So this is the expression for b at n. Remember, what we're trying to calculate is bn. That was what we started with, that formula. So this is the general bn expression. And now let's work out some of the coefficients. And all that requires is, if we're finding b1, we substitute 1. If we're finding b2, we substitute 2, and so on. Okay, so here I've substituted 1, 2, 3, 4, and I've set up b1, b2, b3, b4 respectively. Okay, so now we can finally write out the full Fourier series expression. We're going to have these terms. So the values we just worked out are the coefficients themselves, and they will have the following sign terms stuck to them. So B1 has the sine of 2 pi over capital T times little t. By the way, 2 pi over capital T of course, is the same as 2 pi f. So this is 2 pi f. And here, this is 4 pi f, 6 pi f, and so on. Okay, so B1, we've got the sine of 2 pi ft. Here's B2, the sine of 4 pi ft. Here's B3, the sine of 6 pi ft. And here's B4, we've got the sine of 8 pi ft. It's an infinite series, so we indicate it like this. Notice the left side is v at t. So this is the approximation for the original equation, right? This is the approximation using 4 terms of a Fourier series. We can also common factor negative 2v max over pi from those coefficients, and if we do that, we'd be left with 1, 1/2, 1/3, 1/4 as the coefficients inside the bracket. Okay, so that was using Fourier analysis on waveform 7. I will also add videos using Fourier analysis on waveforms 9 and 5. So those will be added to your module 4 folder also. Okay, thanks for watching and have a good day.